Okay, so in this video, we're going to be talking about 2x2 system of equations and how to solve a system of equations using substitution. Now, I've already done videos on elimination in the past, so make sure you check out that video because elimination is actually an easier method in my opinion. Substitution does have its purpose, but typically I'm going to be using elimination most of the time. Don't get me wrong, substitution is still important and you should know how to do both methods. So this video here is going to be all about substitution and how to solve a system of equations using substitution. Now, before we get into these problems, we want to talk about what is a system of equations. So a system of equations is just when you have two equations and two variables, hence the name a 2x2 system of equations. And essentially what you're trying to do, you're trying to solve the system of equations, meaning you're trying to find the intersection point. That's what it means when they want you to solve a system of equations. You want to find the intersection point or where they're crossing. So I have three pictures below here, and you can see that the possibilities are one solution, no solution, and infinite solutions. Now, if you have one solution, that means that those lines are going to be intersecting at one point. Okay, that's considered one solution, and that happens probably 99% of the time. Now, if you have no solution, that means that your 2x2 system of equations are actually going to be parallel lines, meaning they never intersect. And if they never intersect, that means you can't have a solution because by definition, our solution is going to be the intersection point. And if you have infinite solutions, that means that both of your equations are the same line. And they're going to be always intersecting, right? They're right on top of each other. So if that's the case, we say infinite solutions, all right? So let's go ahead and try our first problem. So the goal here with substitution is not to eliminate a variable like we were doing before with elimination. We actually want to do exactly as it sounds. We want to substitute in. So before I go ahead and try this problem, I'm going to label it, and that's something you should do as well. So I'm going to call this equation 1, and this will be equation 2, okay? And so the goal is you want to substitute one of the variables into one of the other equations. Now, you want to look for the variable that's already isolated. You know, sometimes that will happen. Like in this example here, if I look at equation 1, the variable is already isolated. I have x equals. That's what you want. So when you're doing substitution, you want to isolate one of the variables. And if it's already isolated for you, go ahead and use that one. So in this example here, I'm going to take equation 1 and I see that x is equal to 8 plus y. I'm going to plug that into equation 2 wherever I see an x. Once I do that, I'll have it all in terms of y and I'll be able to solve for y. Okay? So let's go ahead and do that. So writing out equation 2, we will have 6 times, now here's my x. What does x equal? X equals 8 plus y. So I'm going to go ahead and plug that in, close it, right? Then I have plus 4y equal to 8. And so now you can see I have the entire problem in terms of y. I can solve for y. I'll get my y value. I can plug it back in and get my x value, right? So what I need to do here, I need to take the 6 here and I need to distribute. 6 times 8 will give me 48. 6 times y will give me 6y plus 4y equal to 8. Let's go ahead and combine like terms here and here. So now I have 48 plus 10y equal to 8, right? I have a few more steps here. I'm going to minus 48 on both sides. Okay. This will cancel. I'll have 10y equal to 8 minus 48. That will give me a negative 40. And then my last step is to divide both sides by 10. So negative 40 divided by 10 will give me negative 4. So y is equal to negative 4. Now that's not your final answer. Remember, we're trying to find the intersection point, meaning we're also going to have an x value here, x comma y. So your solution will always be written as a point. So as of right now, I only have 50% of the problem done. I have to get the other 50%. To do that, I simply take y and plug it back into either one of these equations, equation 1 or 2, it doesn't matter. Pick the path of least resistance. They're both going to give you the same answer, so pick the equation that's easier. Equation 1 looks easier to me. So I'm going to write x is equal to 8 plus y, which my y is negative 4. So I'm just going to put here minus 4 for y. So 8 minus 4 will give me 4. So x is equal to 4. Okay, so here's my x value, here's my y value. We want to write it as a point. So our final solution is going to be 4 comma negative 4, right? Remember, this is x, this is y, x comma y. And there it is. So you do want to write your solution as a point, and that is substitution. All right, so let's go ahead and try a couple more problems. So here's my next example. Let's go ahead and label everything. Equation 1, equation 2. Notice on this one here, I do not have a variable isolated, okay? Now, typically, if it were me, I would probably solve this problem using elimination because I have both equations in standard form. And when you have both equations in standard form, typically you want to solve using elimination. But they want us to solve by using substitution. So what we need to do is isolate one of these variables. Now, pick the path of least resistance because it doesn't matter what variable you isolate. Now look at this one here. I have a negative 2 in front. This one I have a negative 7 in front. This one I have a positive 3 in front. But this x right here, there's nothing in front. Technically there's a 1, but that doesn't even matter. So this is going to be the variable I want to isolate. It's going to take the least amount of steps to get it isolated. So getting rid of this stuff here, I'm going to take equation 2 and I want it to say x equals, meaning I have to take this positive 3y and I have to move it over to the right-hand side. If I do that, I'll have to use subtraction, right? So I'll have x equals, moving this 3y over, I'll have 2 minus 3y, just like that, okay? And now that I have the variable isolated, I can take it and I can plug it into the top equation right here into x. So doing that, I'll have negative 2 times my x is 2 minus 3y. Okay? Then I'll write negative 7y equal to negative 4. So now you can see I have it all in terms of y. Let's go ahead and take the negative 2 and distribute. This will give me negative 4, positive 6y, minus 7y equal to a negative 4. Combine like terms here and here. I'll get negative 4. This will give me negative y when I combine equal to a negative 4. Okay, a couple more steps. This negative 4 here, I'll have to add, so plus 4. It will cancel here, and also it will cancel here, meaning it's going to be equal to 0. So I get negative y is equal to 0, or in other words, y is equal to 0, okay? So now we have to plug it back in to get x. Now I can plug it back into this equation right here that I rearranged. That's totally fine. And that's exactly what I'm going to do here. So I'm going to write x is equal to 2 minus 3 times 0. That's my y. What happens here? Well, this whole part right here cancels out. I'm left with x is equal to 2. Okay, there's my x value. So now I have a point. It's going to be 2 comma 0. Let's go ahead and write that down. So 2 comma 0, again, that is x comma y. There is my solution, all right? So every single problem we've done so far has had exactly one solution. Let's try the last two problems now. So here's the next problem. We're gonna go ahead and label everything. Here's 1, here's 2. And again, we wanna isolate a variable here. Looking at both of these equations, what variable looks like it's going to be the easiest one to isolate? And looking at it, it's going to be this one right here, right? That x variable. So we're going to take equation 1, we're going to rearrange it by moving this positive 3y over to the right-hand side, okay? To do that, we'll have to minus 3y. So we're going to rewrite the equation. It's going to be x is equal to 6 minus 3y, right? And now we're going to go ahead and take this x and plug it into this equation here, okay? So we're going to have 3 times, here's my x, it's going to be 6 minus 3y, okay? Close it, plus 9y equal to a negative 3. Now we must distribute, right? So 3 times 6, 3 times a negative 3y. Here I get 18 minus 9y plus 9y equal to negative 3. Now look what happens here. When I try to combine like terms here and here, these cancel out, meaning I lose that variable and I'm left with a statement. And that statement is going to be 18 equal to -3. So here's what you have to remember. Whenever you're doing these system of equation problems, whether it be substitution or elimination, if the variables end up dropping out, you have two possibilities. You're either going to have no solution or you're going to have infinite solutions. Now, in this example here, both variables dropped out and I'm left with a statement. And the statement says 18 equal to -3. Is that a true or false statement? And that is a false statement. So if the statement is false, that means there's going to be no solution. This one here is no solution. Okay? So again, if both variables drop out and the statement is false, that means no solution. Now, if the statement were to be true, that means it would be infinite solutions. So this problem right here is no solution, meaning both of these lines are going to be parallel. They never intersect, right? Okay, let's try one more example. So here's our last example. Let's go ahead and label. And again, look for the variable that you want to isolate. Which one looks like the easiest? Well, it's going to be this one right here, this y variable, right, on equation 2. So we're going to take this 8x and we're going to move it over to the right-hand side. Okay, so let's go ahead and do that. So I'll have here y is equal to, moving this 8x over, I get -8x, right? And then -2. Okay, so there it is. Now I can take this and plug it into equation 1 wherever I see y. So doing that, I get -16x minus 2 times, now here's my y, -8x minus 2 equal to 4. We need to distribute now. So here I'll have -16x. I'll get +16x when I distribute that -2, and then I'll get +4, all equal to 4. Now look what happens when you combine like terms. Just like the other problem, these variables are going to drop out, right? They cancel each other out. And I'm going to be left with 4 is equal to 4. So again, both variables dropped out. I have two possibilities, no solution or infinite solutions. Now this statement is going to be true, meaning my solution here is going to be infinite solutions, right? So infinite solutions. Okay, and that's it. And so this tells us that we are dealing with the same line here. Both of these equations are the same. They are going to be intersecting an infinite amount of times because, again, they are right on top of each other. So that is a 2x2 system of equations solving using substitution. I hope that you found the video helpful. If the video did help you, if you could please go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.